Welcome guys, 5.4, applying slope-intercept form. Okay, so we got our standards, applying functions, graphing, and interpreting linear models. And we learn how to apply functions, so applying in slope-intercept form by identifying its slope, which is the rate of change, and the y-intercept, which is the initial value, and the x-intercept. Okay, so as Gustavo's fair, many of the games can be earned tickets that can be redeemed for prizes. Determine the function m of n that represents the total amount of money you have left after playing n games at Gustavo's fair. So let's break that down. Okay, so we have $30 to spend. We know that. All right, so we have $30, and it costs $2.50 per game played. Right, and we want to write a function m of n. So we start with that m of n, and that'll be our money left over. So we start at $30, and then it costs $2.50 for each game played. So are we adding $2.50 or are we subtracting? Right, we start with 30, and then we're spending money, so we're subtracting. Right, so we're going to subtract $2.50 for each game. Okay, so I'm going to represent that. So $2.50 for each game, and n represents games, so we put n. Right? Because m of n equals your money, n equals your games. Okay, so we have an input games, output money. So to simplify this, so m of n equals 30 minus 250 times n, and that's our equation right there. So that's our function, m of n. How much money will you have left after 4 games played? So we want to use 4 games. Games is n, right? So we're using n equals 4, and we substitute it into our equation. So we have m of n equals 30 minus 2.5, or 250n, and we do find m of 4 for 4 games. So 30 minus 2.50 times 4, or 2.5, same thing. And we get 30 minus 2.5, or 250 times 4, that's $10. So 30 minus 10, you have $20 left. So how much money do you have left after 4 games? $20 after 4 games. Make sure you have your units, answer the word problem. Right, so $20 after 4 games. As an ordered pair, right, our input was 4, and we got an answer of 20. So our ordered pair will be 4, 20. Right, again, so input 4, output 20. All right, so we got one of them, 4, 20. That's 1 point. Okay, part C. Label both the horizontal axis and vertical axis, then graph the function using the y-intercept and slope. Okay, so remember our input value is always on our x-axis, right? So our input was games and our output was money, right? So input games, output money. So input games, and that was represented by n, and our output is money, and that was m of n. Okay, so we labeled our axes, and then we're going to graph the function using the y-intercept and slope. So again, we're going to write down our equation. M of n equals 30 minus 250 n. So here's our equation. So we want to graph this just by using the y-intercept and slope. So we can identify what the y-intercept is, identify what the slope is, right? So your y-intercept, again, is your initial value. So what number did we start with? How much money did we start with? Right? We started with 30. So $30, that's our initial value. So that means that's our y-intercept. Initial value. And then our rate of change, we're losing or we're spending 250 per game, 250 per game. So that is our rate of change, right? So that is our slope, which is our rate of change. Okay, so we're going to use that to graph it, right? So we know our M, our slope is negative 250. Our y-intercept B is 30. So on our graph, we start with $30. So we're going to graph this and go by intervals. So we got to make up to 30, and then we're going down, right? So let's skip every line, 10, 20, 30. And our games can just be 1, 2, 3, 4, 6, 7. And then we represent. So we start at our initial value, right? So we start at 30 because that's our initial value. So we start at 30 on our graph right there. So we start at $30 and then we go down 250 for every game, 250 for every game, 250 for every game. So if we go down 250 for every game, every 2 games we go down $5, right? So we can do, so instead of going like half and then 1, half and then 1, you can just do $5, 2 games, right? These are all points right there. $5, 2 games, $5, 2 games, $5, 2 games, all the way. $5, 2 games. Draw a line right there. And then we can tell if we continue on our graph, we're going to run out of money at 12 games. Okay, number 2. Okay, determine the intercepts of the line. So y-intercept, when you look at it, it's right there on the y-axis, right? And your x value is always 0. So 0, -6. Your x-intercept is right here, right? So your x value is -8. Your y value is 0. Okay, part B. So we can do y-intercept is at -10. So y-intercept is on the bottom now. They switch it up on. So 0, -10. Your x-intercept is right there. Your x is 3. Your y is 0. Okay. So you're always going to have zeros in your intercepts on your graph. Okay, number 3, Zane's elevation relative, should be an L. So relative to the edge of the inside of the volcano in meters as a function of time in seconds is graphed. How far was Zane from the edge of the volcano when he started climbing? Right, so remember our initial value is always our y-intercept, right? So this right here is our initial value, and that's our y-intercept, right? So that started at -25, right? So 0, -25. So when he started climbing, he was at -25 meters. So -25 meters. And then how long did it take Zane to reach the edge of the volcano, which is at 0 elevation, right? So you look at your graph, you just follow it. Where does it intersect? Right there. So it took him 35 seconds. Right, so that's 35, 0. So 35 seconds, 0 elevation. So 35 seconds. And how fast did he climb? Right? That's your rate of change, right? So rate of change. So that's our slope. So we want to find what is the rate of change, which is slope. So we have 2 points. So given those 2 points, 0, -25, and 35, 0, we can always find what is the slope. We can use y2 minus y1 over x2 minus x1. Right, so we got x1, y1, x2, y2. So we got 0 minus -25 over 35 minus 0. So that's going to be 0 plus 25 over 35. We got 25 over 35, right? And we can reduce it by 5. Divide top and bottom by 5. So we got 5 over 7. So our rate of change is 5 over 7. Well, what does that mean, right? So our rise, which is meters, right? So meters, and this is seconds, because it's dealing with meters per second. 5 over 7 meters per second. Okay, number 4. Let's go. Anumeha mows lawns. He charges an initial fee and a fee for each hour of work. So I give you F of T represents Anumeha's fee in dollars for working T hours. So here's our function. How much does Anumeha charge for each hour of work? And then what's the initial fee? So we can identify what this is, right? This is the slope. This is the rate of change. This is the y-intercept. This is the initial value. So we want to find what is the slope. So looking at the equation, whatever is next to the variable, t, that is our slope, right? Our rate of change. So how much does she charge for each hour of work? 12. And it's in dollars. So $12 per our t, which is hours. So $12 per hour. We don't need the S there. So $12 per hour. Initial fee is the number by itself. So 6. That's our y-intercept, right? Our B. So $6. How much would it cost for 3 hours of work? So we just find what is F of 3. So we get 6 plus 12 times 3. So 6 plus 12 times 3, 36. Add those together, we get 42. So $42 for 3 hours of work. Like that. Right, so all we did was identify what the rate of change is. 12 next to the variable, 12 per hour, $12 per hour. Initial fee, $6. Right, you want to find 3 hours of work, you substitute 3. F of 3, calculate it. You get $42 for 3 hours of work. Bam. Okay, 5. Mr. Mole was left in his burrow and started digging his way down. A of T, his altitude relative to the ground in meters after T minutes. So again, you identify. What can you identify? You know what the slope is right there. You know what the initial value is, which is your y-intercept, right? So this is rate of change, always. And this is your initial value. Right? So how fast did Mr. Mole descend? You look at what is the rate of change. This is negative 2.3. So this is negative 2.3, and then we going in meters, right? So meters and minutes. So negative 2.3 meters per minute. And then how far was Mr. Mole digging? Underground when he started digging, that is your initial value, right? So initial value right there was his negative 7. So negative 7, and we're working in meters, so meters. So he was 7 meters down and negative 7 meters relative to the ground, right? His initial value. So what is Mr. Mole's, rate of change? So what is Mr. Mole's altitude relative to the ground after 10 minutes of digging? So you just gotta find what is A of 10. So negative 2.3 times 10 minus 7. So negative 2.3 times 10 is negative 23 minus 7. So negative 23 minus 7, negative 30. And this is feet, right? So negative 30 or meters, negative 30 meters after 10 minutes. Okay, so he's deeper, so he's going down, which makes sense because he's digging down. He started at -7 meters. He dug for 10 minutes at 2.3 meters per second or per minute, and then he does end up at -30 meters after 10 minutes. So how far does Mr. Mole dig every 4 minutes? Every 4 minutes. Okay, let's see. So every 1 minute, it's -2.3. So to figure out how far they dig after 4 minutes, every 4 minutes, you have to take -2.3 and multiply it by 4 minutes. Then you find how far you dug after 4 minutes. So -2.3 times 4, we got -9.2 meters. Okay, so you're saying he's going down 9.2 meters, or if you ask how far does he dig, he's digging 9.2 meters every 4 minutes. Okay, number 6. You can do those. Those are review questions solving Khan Academy. There you go.